All right, so this is going to be a video about solving quadratic structure equations, and I have 5 example problems basically right here that I'm going to be working through to kind of cement that concept a little bit more. So, all right, so that first one, I'm just going to copy it down real quick, and I'm going to put it in standard form. So I'm going to subtract off that t squared minus 2 to the other side and the 2 as well, and then setting this equal to 0. Okay, now from here, I'm going to set my u equal to this part right here. So it's going to be t squared minus 2. And then you can rewrite the original equation to be u squared minus u minus 2 is equal to 0. Okay. Now from here, I am going to do quadratic formula. So it's going to be u is equal to negative b, which is just 1, plus or minus b squared, which is 1, minus 4ac, which is 4 times 1 times negative 2, which is going to be negative 8. And then we're doing the square root of all that. And then we're dividing it by 2a, which is 2 times 1. So I'm just going to put a 2 down here. Okay, I'm going to simplify some things here. So that becomes a plus plus. And then you end up with 1 plus or minus the square root of 9, which is 3 over 2. Okay, now I'm going to do the plus version of this. So I'm going to do 1 plus 3 over 2. So 1 plus 3 is 4 over 2 is 2. And then I'm going to do 1 minus 3 over 2. Which is going to be negative 2 over 2, which is negative 1. So for our answers, we end up with u is equal to 2 and u is equal to negative 1. Well, u, if you remember, is equal to t squared, this right here, t squared minus 2. What I'm going to do is replace that u with t squared minus 2 is equal to 2, and t squared minus 2 is equal to negative 1. Okay, so both of the u's were replaced with t squared minus 2. That way we can solve for t. It's the whole goal of this problem. So I'm going to add 2 to the other side. So you're going to have t squared is equal to 4. I'm going to add 2 to the other side here, and you're going to have t squared is equal to 1. We're going to do the square roots of both sides, and you're going to be left with t is equal to plus or minus 2 here, and t is equal to plus or minus 1 over here. Now, if you notice, there are 4 answers we have because we have positive 2, negative 2, positive 1, negative 1, so that's 4. If you look up to the original problem, based on the fundamental theorem of calculus, you should have 4 because you have this, something that's squared over here. So that means the highest power in this problem is going to be to the 4th power. So that means you should have 4 answers, and we do. So technically we are done with this problem and we can move on to the next one. All right, the next one is x to the 8th minus 13x to the 4th plus 36 is equal to 0. Really important to understand with this one is that you should have 8 answers because it's x to the 8th. So this one's going to be a little bit different than the last one that just had 4. Okay, I'm going to rewrite the equation really quick. All right, so from here you should notice that it is a quadratic in form problem because quadratic structure, because this, if you double it, you get the power over there. So that means we're going to need to use u here and set that equal to x to the 4th. So now if we rewrote the equation, it's going to be u squared minus 13u plus 36 is equal to 0. Okay. Can't use quadratic formula on that white step, but the orange step you can. And that's the whole point of doing this using quadratic structure. We're going to use quadratic formula here. So it's going to be negative b plus or minus the square root of b squared, which is 169, minus 4ac. So it's 4 times 1 times 36. And you end up with 144. We're going to divide all this by 2 times a, which is 2 times 1. So it's just going to be a 2 here. And then this is going to simplify to 13 plus or minus the square root of 25. Because if you subtract this and this, you get 25. Or 25 in there. So you're just going to end up with a 5. And then this is going to be divided by 2. So you're going to have 13 plus 5 divided by 2, which is going to be 18 divided by 2, as well as 13 minus 5 over 2, which is 8 over 2. So your 2 answers are going to be 9 and 4. So it's 9 and this is 4. But that's for u. You still have to solve for x. You still have to solve for x because the problem started in terms of x. So we're going to say that u is equal to 9, u is equal to 4, and x to the 4th is equal to u. So we're going to do it like this, and then x to the 4th is equal to 4 here. Okay, we're going to take the 4th root of each side. fourth root, and fourth root, fourth root, fourth root. Okay, also it's important to understand that you have to have the plus or minus when solving these because you have an even power that you're dealing with. It's x to the fourth. So since x to the fourth is even, you have to have plus or minus. So you're going to have x is equal to plus or minus the fourth root of 9. And then this one's going to be x is equal to plus or minus the fourth root of 4. Okay, now that is 4 answers and we're supposed to have 8. But so to get those other answers, we have to resolve these equations only using factoring. So it's going to be a little bit of a curveball here. So we have this x to the fourth is equal to 9. I'm going to subtract 9 from both sides. So you're going to have x to the fourth minus 9, like that, equal to 0. From here, I'm going to factor this using difference of squares. So we're going to have x squared plus 3 and x squared minus 3 is equal to 0. Now from here, we're going to solve. We're going to have x squared plus 3 is equal to 0, and then x squared minus 3 is equal to 0. So from here, I'm going to subtract off this 3 here, and you're going to have x squared is equal to negative 3. I'm going to take the square root of both sides, and you're going to be left with the square root of 3 times I, and it's going to be a plus or minus on that. So there's 2 answers right there. And then I'm going to do the same thing here. I'm going to add the 3 to the other side. So you have something like this. We're going to take the square root of both sides, and you're going to be left with x is equal to plus or minus the square root of 3. So now we have 4 answers here. If we do the same thing on the other end over here, we're going to end up with the other 4 answers. So we'll have 8 answers in total, essentially. Highlight these answers real quick. So the other one was x to the fourth is equal to 4. So I'm going to do the exact same thing that I just did here. So we have x to the fourth is equal to 4. I'm going to say x to the fourth minus 4 is equal to 0. Okay, I'm going to factor this to be x squared minus or plus 2 and x squared minus 2. So it's really similar to the other one we did, only it's 2 instead of 3. Okay, we're going to solve this out. We have x squared plus 2 equals 0 and x squared minus 2 equals 0. And then we're going to have x squared equals negative 2, x squared equals 2. We're going to square root both sides, do the plus or minus on them. You should have x is equal to the square root of 2i, because you're going to do the square root on both sides here, and you'll have that square root of a negative. You do have to have the plus or minus. This one, you're going to have x is equal to plus or minus the square root of 2. And then you end up with the other 4 answers. So if you notice, if we count all these answers up, there's 2 here, 2 here, 2 here, and 2 here. So that ends up being 8, which is how many solutions we're supposed to have based on the power of that polynomial, the degree of the polynomial. All right, so then I'm going to copy down the next one real quick. So it's going to be x to the fourth minus 10 is equal to negative 3x squared. All right, I'm going to put this in standard form first. So I'm going to add the 3x squared to both sides. So it's going to be x to the fourth plus 3x squared minus 10 is equal to 0. All right. From here, I noticed that this, if you double it, you end up over here. So we are quadratic in structure. So we're going to say that our u is equal x squared. And then I'm going to rewrite the equation so then it's a quadratic structure equation, and we can use quadratic formula to solve it. Okay. So if u is equal to negative b plus or minus the square root of b squared minus 4ac, which is going to be negative 40. And we're going to divide this by 2a, which is just dividing by 2. Okay. This goes plus and plus, and you can kind of rewrite this here. Instead of 9 plus 40, I'm just going to write a little 49 in here. Write a little 49 in here. So we're going to do the square root of 49. So you end up with negative 3 plus or minus the square root of 49 is 7 over 2. So this ends up being equal to 4 over 2 and negative 10 over 2. So your two answers for u are going to be u equals 2 and u equals -5. Okay, but we need to solve this in terms of x, so I'm going to substitute the x in there. So it's going to be, or x squared, I should say. I'm going to substitute the x squared in for u, and you get x squared equals 2 and x squared equals -5. Okay, square root both sides, and you end up with x is equal to plus or minus the square root of 2, and x is equal to the square root, x is equal to plus or minus the square root of 5 times I, because you're going to do the negative, square root negative there. And if you notice, you end up with 2 answers here and 2 answers here, and the problem is x to the 4th, so there should be 4 answers, which you have, so then you know you're done with the problem. Okay, on to the next one. We have 2y plus 3 times the square root of y minus 2 is equal to 0. So I'm going to rewrite that plus 3 times the square root of y minus 2 is equal to 0. Okay, this one might not be as easy to see if it's quadratic in structure or not. It is, but one easy way of doing this is just turning that square root of y to the 1/2. So we end up with something like this. Okay, now if you notice, if you double that middle power, this right here, if you double it, you end up getting the power over here, which is a 1. Okay. So we're going to use that to our benefit here. Solve this out. So our u is going to be equal to y to the 1/2. So you can rewrite this entire equation to be 2u plus 2u squared plus 3y minus 2 is equal to 0. Then we're going to use quadratic formula to solve for u. So we're going to have u is equal to -b plus or minus the square root of b squared, which is 9, minus 4ac, which is 4 times -4, which is going to be -16. And then this is all going to be divided by 2a, which is 4. Well, this inside the radical part here is going to be the square root of 25. So I cancel this out. So you just have the square root of 25 in there, which comes out nicely. So you're going to end up with -3 plus or minus 5 over 4. Which means you have as possible answers 2 over 4 and -8 over 4, okay, as your u's. So since that's what u is equal to, I'm going to write that up here. So u is going to be equal to 1/2, and u is going to be equal to -2. And if you remember, our u is equal to the square root of y. So I'm going to write that in there, y to the 1/2. Is equal to 1/2, and then you have y to the 1/2 is equal to -2. Now, one thing I do want you to see really quick here is you can't take the square root of something and get a negative. So right here, there is no solution. Okay, you can't actually solve that one out. This one you can though. You just square both sides, and the 1/2 and the 2 cancel, and you're left with y is equal to 1/2 times 1/2, which is 1/4. Which is the one answer based on this equation here. It looks like there might be multiple answers, but this is not a polynomial, so it doesn't actually follow the fundamental theorem of algebra anyway. So the only answer for this one would be 1/4. All right, so we got one problem left here. It's going to be, let's see here, x to the 5th minus 11x cubed plus 10x is equal to 0. Okay, so you might look at this and go, how is this quadratic structure equation? It's actually not right now because you have to factor out an x first to put it into that structure. So we're going to factor out an x real quick. And you are going to have to do this sometimes. So if you ever look at a problem and go, oh my gosh, how do I solve this? Just think about what you can do. In this case, you can factor it. So hopefully that'll help you out a little bit. And then you can see if you double this middle power, you end up with the first power there. So then you can kind of see that it's quadratic in structure. So just for this part right here, I'm going to use quadratic structure for it. So our u is going to be equal to x squared. It's also important to note we should have 5 answers for this based on the fundamental theorem of algebra. So I'm just going to solve this part right here. I'm going to highlight it in orange just so I'm very clear. So I'm only going to be solving this part right here. And I'll try to color code it. So you're going to end up with u squared minus 11u plus 10 Okay, we're going to set this equal to 0. It is important to understand too that this x right here is still one of the solutions. So we have one solution right away as x equals 0. So I'm going to put that over there. All right, so here we have u squared minus 11u plus 10. I'm going to use quadratic formula on this. So it's going to be negative b, which is negative 11. So it's going to be 11 plus or minus the square root of b squared, which is 121, minus 4ac, which is 40. And we're going to divide all this by 2a, which is just going to be 2. Inside this radical, you can simplify this, and then it's just 81, which is nice because that's a perfect square, so the square root will come out evenly. So you're going to have 11 plus or minus 9 over 2. So you're going to have 11 minus 9 over 2, which is 2 over 2, and 11 plus 9 over 2, which is 20 over 2. So those are our two answers there. For u, but we do have to solve them for x. So that's going to be our next step here. We're going to say that u is equal to 1 and u is equal to 10. U is equal to x squared, so I'm going to put an x squared in here for each of them. Substitute that in. Square root both sides, you end up with plus or minus 1 here. Over here you have plus or minus the square root 10. So now if you count up all these answers, we have 1 here, 2 here, and 2 here. So that's 5 total, which is how many we're supposed to have. And that is actually the answer for that problem. So those are a bunch of example problems involving quadratic structure equations. If you have any questions about anything in this video, let me know.